Hey, it's Alex Williams with the new stack here in Copenhagen for KubeCon plus Cloud Native Con, and I'm joined right now by Steve Spiker and Ben Hurries. They're both with Red Hat. How are you guys doing?
Good. It's been a really good experience so far.
Has it?
Day and a half of
KubeCon. Yeah, I was just asking you guys what sessions you've been attending, and you're mentioning CI/CD, and what was the sessions you've been attending at all?
Some of the CI/CD and also other developer experience focused sessions about how application developers are getting their products onto the platform.
Right, because you lead developer experience, you're saying, at OpenShift.
Yeah, that's right. I lead the developer experience team for OpenShift, so we're focused on everything about turning source code into images and getting it running through a CI/CD pipeline.
So, and Steve, what's your focus at Red Hat these days?
So I work with Ben on developer experience. He's on the engineering side. I'm the product management side. And one of the things mentioned is we want to make sure we have a really smooth, seamless experience, developer experience. But the other aspect of it is a lot of people come to Red Hat is the security aspect of it too. So not only you got to make it a smooth experience, but you got to make sure that the operators have control over securing the platform and keeping the builds and the software up to date.
With CI/CD and Kubernetes, what are some of the frictions there? What are some of the frictions that are affecting developers right now?
CI/CD is kind of an interesting one. There's some people who've invested in a certain amount of tooling over the last, even decade as far as how they automate their build artifacts, and some people have updated those things to then be container aware, Kubernetes aware. That's one aspect of it. Others has just been the amount of change, amount of issues around just the transformational changes that within the organization of people has been part of it. Sometimes it's not even the technology. As far as the challenges itself with the platform, Kubernetes and tooling, it's some of the things we talked about is like ensuring it runs securely on the platform. A lot of people want to leverage Kubernetes for the build and the pipeline itself. And so that's one of the things that we're talking about while we're here and learning more about what people are interested in, and is how better to leverage the platform to do CI/CD.
I would even maybe reclassify it as not just a challenge, but an opportunity. You have people that have developed systems of build farms and CI/CD infrastructure, and then their deployment platform. With Kubernetes and OpenShift, you have the opportunity to put that all in one, where your cluster is both your build platform, your test platform, and your deployment platform.
Right.
Easy to scale up multiple instances, test them, run your builds there, scalable infrastructure.
So that leads to the question about the state of building images, and how we're viewing how images are being built right now for Kubernetes. What's that narrative? What has been that narrative over the past 2-3 years that you see maturing now?
Yeah, so I think that's where we really see, especially with some of the sessions that I've been to, and one of the sessions I'll be participating in later today, the evolution from it's just doing a Docker build on your developer workstation, pushing that image to Docker Hub or a registry, and then pulling it down to Kubernetes. Kubernetes was a platform to run images, but you were on your own to produce those images. And now we're starting to see people get interested in the problem of how do I build those images securely, reproducibly, and again, can I use the platform? Docker build requires a lot of permissions that you may not want to give everyone to produce your images. It's fine to do it on your workstation, maybe not okay to do it on a shared cluster. So now we're starting to see some additional tools coming out, things like the S2I tool, the Conoco tool, and a few other tools around building images that give more flexibility to do it in a secure way and do it on platform.
What are these new tools trying to do that is an improvement upon what developers relied on before?
I think some aspects of it were just to expose security surface attack area. So typically people have leveraged Docker builds, which always requires a daemon to be up and running, which it does a lot more than just container builds. And so a lot of people are looking to take some of that capability, like we've done with the tool Builda, and allow it to be a daemonless tool and to be able to have kind of a secure way of doing that, or reduce the attack footprint there. And so we're seeing a movement towards that direction. So and you mentioned Conoco is a tool that's trying to leverage more even how to build within pods or in containers on the platform. Yeah.
Conoco's the name.
Yep. Mm-hmm. So various interesting techniques there that we see people are approaching.
Why? Why are we seeing these approaches?
Well, I mentioned is just trying to reduce the amount of security attack surface area. The other is leveraging the clusters themselves. So if they have these certain requirements on what they can and can't run in a secure way, they want to make sure that these solutions can be run in a safe way and leverage that investment of the cluster themselves. We have a number of customers who've moving away from the VM workloads and looking towards containerized solutions, and build should be part of that too, and they should be able to leverage that for their CI/CD tooling, for their build tooling, or container-based tooling.
It all comes down to what you put in the container. I mean, and how you think about that artifact. I mean, that's the user space in many ways, isn't it? But now what we're talking about here is a little bit differently about how you're thinking about the source to image. Take us through that kind of that developer pattern, workflow that you're starting to see emerge. I mean, because containers started with Docker, right? Just as in terms of popularity, when they became so easily be able to be reproduced, right? You could create, it was just very simple to do. But then people were putting all these, everything, they really didn't know how to use the container necessarily. So there was a lot of a whole kind of cycle of people just kind of figuring that out. And then Kubernetes arrived, right? And we started to see Kubernetes as an orchestration tool, and that's changed quite a bit in thinking, allowing the developer not to have to think about the orchestration of all those containers themselves, but using an orchestration platform like Kubernetes. So I'm just curious, through that progress and that development, where is that developer experience now? When they're actually going out to build their containers themselves, and what is the guidance then as this progresses into a Kubernetes distribution?
So I think that's where the current challenge is how to build a good image. So it's very easy to build an image, but there's some best practices around how do you produce an image that's going to expose the right ports, not be overly bloated with content you don't need. When you go to rebuild it, how can you rebuild it efficiently? So for people who are used to writing Docker files, there's an ordering to how you want to write that Docker file so that when you rebuild it, you can reuse as many layers from cache as possible. And so that's where I see some of these additional tools starting to help make that easier on developers, that you don't want to hand them the full power of a Docker file and say, do it right. You want to give them a base image that is the framework they need to use, and all they have to do is supply their source code. They're not writing a full Docker file. They have less room to make mistakes or do something that's not going to be performant. They just come with their source code. Let the tool combine that source code with a known good image for the kind of application they're writing, and keep them from going off the rails intentionally or accidentally.
Right, inevitably you're going to go off the rails at some point, but you don't want to go off the rails too bad, right? You want to try some things out. You're going to test. You're going to find what works for you, what doesn't work for you, just like in anything, right?
I think one of the interesting things, all the things that Ben talked about that you have to work through, is one of the things we focused on over 3 years ago, before even Kubernetes 1.0 came out, when we had our source to image process on the platform. It's really kind of driven by the PaaS simplicity. Is I just want to give you a get URL and I want you to build it. And so we focused on that simple interface on how you can interact with taking your source code and containerize it, and all of the complex things that Ben talked about, like the best practices, how you build images, and wrap that around a process on the platform through our source to image as aspects of that, and it reduces the amount of attack surface area from the Docker build process.
Interesting. So now we're talking a little bit here about the building of the images. Source to images is an emphasis that we're hearing more from Red Hat discussing kind of this concept of source to image. Tell me, what is the developments that you're looking at making, kind of in your own tool sets to kind of make that developer experience better?
Do you want to speak to some of the ROAR efforts, or?
There's a number of things. There's, as far as the source to image aspects, one is.
Maybe we should just start with an overview of what it is, right? It's a toolkit of workflow for building these reproducible, Docker images from source code, right? So what does S2I produce then? What does it produce?
Yeah. So you can go ahead.
Sure. So source image it produces an application image, and so we talk about it as you have your builder image, and so you can write your own builder image, or you can consume a builder image that the community or your organization has built, and the builder image contains all the content needed to run any application or framework. So it might be a Wildfly runtime or a Ruby runtime, and also the tools to compile any source code that you would need to run on that platform. So that's your base image. And then source to image will take that builder image, execute a known set of what we call assemble scripts, which will take your source code, perform transformation operations, whether that's compilation, pulling down dependencies, moving files around into deployment directories, to restructure that source code into a runnable state. And so the flow for source image is start up the base builder image, add the application source to it, invoke the assemble script to transform the source code into a runnable state, and then commit that new container as what we call the application image. And so that's why we go say you're going from source to image. You provide the source, either you provide the builder image or you've selected a builder image from the ecosystem, and then what you come out on the other side with is an application image. And again, it's sort of tightly controlled in that the assemble script is handling what's done to transform the application. You're not yum installing arbitrary packages, you're not performing root operations, you're just doing typical developer application compilation operations.
Yeah, the other thing I was going to say, one way to think about it too is sometimes it helps to compare and contrast it to what people know or used to. So Heroku and Cloud Foundry popularized this concept around build packs, and so it's a language sort of specific way to understand how to give it some source code, transform it into containerized application, and have it deployed. And in some ways, it's analogous to that, I would say, and how to think about how it works. It's just done in a more, I guess, Docker-centric or Kubernetes-centric way of thinking about the containers and how you want it to be built and then prepared for deployment on the Kubernetes.
So once that's a good overview. But how does it work then? How does it work for the developer? What is that process that they're going through when they're actually, putting it into action?
So source image is available both as a standalone command line tool where developers can run it locally. In that case, you don't have Kubernetes involved at all. You just have a local Docker daemon and the S2I tool, and you just invoke S2I build and either your directory of your local source repo or point to a GitHub repo, and then the builder image that you want to use with that, like a Ruby builder image or a Wildfly builder image. And that will produce a new output application image, and then you can Docker run that image or Docker push that image to someplace. So that's the most simplistic level when you're using it as a CLI. You can also use it on OpenShift itself as a build option that OpenShift provides for building images. In that case, you just provide OpenShift with the Git URL that you want to build, and again, the builder image, and OpenShift takes care of pulling down that builder image, pulling down your source code, and then pushing the resulting image to a registry so it can be immediately deployed on the platform. Mm-hmm. So once you're using it within OpenShift, the experience becomes completely push code to Git repo, and either a build can be automatically triggered or you trigger a build, and then that new image can also be automatically deployed. So it can be as easy as push code, wait for new deployment, and then review changes.
I would say the simplest experience I think of like a developer interacting with is like if source image is already pre-set up, they have their existing cluster, they can just like OC new app dot in the Git repo, the local clone repo, and it will create all the necessary things to even start building an application. And then from there, as Ben talked about, you could just hook up your webhooks from GitHub to trigger the builds whenever you do a git push to that repo, and then it's all completely automated. So it's actually a pretty simple and low barrier of entry for developers to use and work with it.
So what are some of the goals here? I mean, the reproducibility is an obvious one, and I've been looking at your on GitHub at kind of what those goals are that you have, and you list them as reproducibility, flexibility, speed, security. The reproducibility issue, I imagine, it could be confounding for end users if they're not able to reproduce something pretty easily. I mean, those are the pioneering days where you'd have to manually do that. What is the automation that's taking place now? What is the infrastructure that you've built to allow for this more declarative environment?
So one of the things that's the biggest value, I would say, to a system like this is that patch process. When their CVEs come out, you need to patch either the JVM or you need to patch the underlying operating system or all those things. You need to roll that out in a secure way, and you need to make sure when you do that, it's a repeatable process. And so through that, we have a centralized registry where you can have the content, and then you can have an image change trigger so that you can notify the build whenever these images change. And you got to make sure, as you mentioned, the repeatable process is that, so when that happens, that's going to happen at a pretty large scale, and it's going to happen to a large number of applications. You want to make sure that system can automatically build those things and then reproduce the final deployable image in a way that's consistent the way the application was running before, just with the system patched as it has been, as you would expect it to be.
So the reproducibility also provides that security protection as well, doesn't it? It can improve. It can provide. Can you inject it with policy then, almost to some extent, to be able to then make sure that those images are updated, for example, with security, updates and
so
such?
The policy aspect isn't so much a source to image attribute, but that's more on the cluster itself.
Right.
You can have policies around what images are allowed, ensuring that images have to be annotated in a way that proves that they were scanned
before
or
they
signed
get there,
or something like that.
Yeah. But when you're thinking about that, think about this continuous integration in these containerized environments. What are still some of the advancements you're trying to make, to kind of make this even more of a better developer experience?
I think one of the things we look at is truly more of a native, lower footprint aspect to how things would be integrated. Today we have an integration with Jenkins, so like as an end user, you kind of know it's a pipeline engine in the background, but you don't have to do a full Jenkins awareness as far as getting hands-on with it. But you do have to set up a Jenkins file in order to have it working. But if you had a stock set of Jenkins files that you would use, and as part of your Git repo, we would just fire up the Jenkins instance. We would do the work that's needed to be done, and then we could tear it down. There's a lot of things we could work to improve in that area, such as the footprint needed to start up a system like that and then tear it down and have it react better. So we've been doing a lot of work with our large scale, kind of a beta we're doing with OpenShift IO, which is a hosted development platform. We're doing some experimentation there around what that would look like. And one of the key aspects of that is sort of this Jenkins piece that's running the pipeline aspects that needs to wake up, do its job, and then kind of go back down, where traditionally a system like that's been built such that it's a long-running, large master system that is satisfying a lot of pipelines. But we're moving more towards this on-demand continuous piece. It's transitioning to either a better Jenkins system for that, or what alternatives could be there.
So I mentioned flexibility as a key attribute here. What's the flexibility then? What is that flexibility that's offered?
So with source to image, the images themselves, the builder images, contain the logic for how to build and run the application, but it is also possible for developers to provide their own logic for that or extend the assemble and run logic. So the flexibility there is you can actually take any image on Docker Hub, provide your own assemble and run scripts to use with that image, and essentially turn it into an S2I builder image.
Mm-hmm. Mm-hmm. And then there's the speed aspect of it. What is that? How does the speed change? I read here that instead of building multiple layers in a single Docker file, SOI encourages authors to represent an application in a single image layer. What does that do?
So by reducing the number of layers, so S2I, essentially you have your base image, builder image, which will have however many layers you produce the builder image with, and then it only adds one additional layer, which is your application code. And that gives you a speed benefit in terms of pushing and pulling, because even if those layers already exist in places, the Docker push and pull process still has to validate each layer to make sure that it's already got that copy. So you're just reducing the number of calls that you're making as you shovel those images around the system, as opposed to an image that might have 20 layers as you added all your different bits of application logic.
Yeah, one specific case of that is that you could think about how that would work on your laptop or your desktop there. If you wanted to do a local build, you would have to probably do some Docker pull that image down. You'd have to do that work, and then you'd have to Docker push it to the place you'd want it. And if it was a new place you were pushing it to, you would have to push the entire image there. With source image, what we do and recommend to our customers is even pre-pull those images to the build host that's going to do it. So when the build runs, it's already going to know it's there. It's not going to have to pull it. And then when it performs the build, there's only that new layer. And then when it pushes that image back to the registry, it's only pushing that new piece that's been there. So speeds things up quite a lot by doing those things.
And with the security, you guys cite that Docker files are run without many of the normal operation controls, right? Containers usually running it. They're usually running as root and having access to the container network. And so, what does S2I do? How does it control the permissions and privileges?
So what S2I does is it's going to start up your builder image running as a non-root user. So it will never, unless you configure it otherwise, never allow you to run that container as a root user. And then it just invokes the assemble script. So the only things the assemble script can actually perform are operations a non-root user can perform. And that differs from a Docker file where anybody can say user root and then, again, perform any root operations that they want, which both means that they could be manipulating the image they're producing in ways you might not want them to do, and also that if they were to escape the container jail, they would be root on the host system.
Yeah, right, okay. So in terms of open source projects that are out there and how they're kind of supporting your efforts and everything else, Kubernetes is critical. What are some of the other open source projects out there that are kind of critical to kind of what you're trying to do here? I don't know if there's any kind of particular, if the OCI kind of, maturity of OCI plays a role in this at all.
And one of the things that we're trying to figure out is that question more is how big of a problem this is for other people in the ecosystem. I know that through the tool like Conoco and some discussions with Google, they're thinking about these things quite a bit as well. And so you could say there's the CRI, container runtime interface. So we're starting to question things. Should there be CBI, like a container build interface or a common build? And so should we start thinking about how we can plug in these other tools, as we had Builder, Docker Build, we had Conoco, we have what's going to be in the new thing that gets up 2,000 stars in GitHub tomorrow. So there's a lot of things like that we're thinking about how we can plug in these alternatives and start to just see from the community where the interest is. And so I know Ben's got a session later today with a colleague, Matt Moore, from a Kubernetes community member, Matt Moore from Google, and tomorrow as well to see, one, to talk more about the subject, and also to see where everyone else is at as far as kind of coming together and looking for maybe more community participation in the build space on Kubernetes.
Well, thank you both for taking the time to talk with me about source to image and some of the other kind of surrounding issues that I think we could talk a lot about, in terms of how we think about this in terms of kind of the whole continuous integration, continuous development workflow, but also in terms of what are those. I think you bring up a good point about, do we need a build initiative, for example, an open source build initiative, so those at least are documented. So thank you very much. Really appreciate it.
Thank you. You're welcome. Enjoy talking with you.